Hello everybody, this is Mr. Kusaj, and we are ready to start chapter 4, Trigonometric Functions. Now, this chapter has so much stuff in it that I split it in two halves. What that means is we're going to have a test halfway through and another test at the end. So it's kind of good news because it's better than waiting to the end of the chapter and forgetting everything and doing bad on the test. So it's better that we take a short test in the middle of this chapter, like after 4.3. Okay, so trigonometric functions, trig functions, those are the sine, cosine, tangent. Don't forget to put your date here, 4-1. Right triangle trig. This is sine, cosine, tangent, right? I know you've heard this before. I know you've learned it before in Algebra 2. So the trig function ratios, they are sine, cosine, tangent. Now you remember what a ratio is? A ratio is a fraction, a ratio, a rate, something over something, right? So there's a ratio called sine, a ratio called cosine, and a ratio called tangent. Okay, so what are they? Well, they work with right triangles. So yeah, let's get to know a right triangle first. A right triangle has a right angle and two other angles, two non-right angles, right? Now, depending on which angle you're looking from, we refer to the sides, the legs, as opposite and adjacent. The hypotenuse is always the hypotenuse, right? That's the diagonal. The L shape are the legs. This is the hypotenuse. That will always be the hypotenuse. Okay? So if we are looking from this angle, this side over here, far away, right? Imagine this is an eyeball and it's looking across the room. Across, opposite, the opposite side of the room. So that's the opposite side. Right next to it is the adjacent. Okay? Opposite, adjacent, and the hypotenuse is always the hypotenuse. Look at this one, right? Same position, but now we're looking from the other angle. So if we look from this other angle, now this is opposite, right? If this was an eyeball looking across the room, this is opposite. And which side is adjacent? Well, it can't be this because this is always a hypotenuse. So this must be the adjacent side. Adjacent means next to, right? If I'm adjacent to you, I'm next to you. Now, your right triangle can come in any position. So you have to be smart enough to know where the opposite, adjacent, hypotenuse are. So if this is the angle, then this is opposite and this is adjacent. And of course, this has to be the hypotenuse because it's a diagonal. Okay? So what are the sine, cosine, and tangent ratio? Now imagine there's numbers all over here, right? The sine ratio, the sine fraction, the sine ratio is the opposite side, the length of the opposite side over the hypotenuse. The cosine ratio is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, again, I know you've seen this before, and a good way to memorize these is with the made-up word SOHCAHTOA. This is so common that you can just type this into Google and trust me, all these things will come up. Okay? Sine, cosine, tangent, SOHCAHTOA. Sine, S-O-H, so C-A-H-T-O-A, SOHCAHTOA. That's a way to remember. Okay? You have to memorize these. If you haven't memorized them already from last year, if it's not coming back to you, you have to memorize these. You really have to memorize these three. You really have to memorize them. Okay? Then, from that, we can get the reciprocal functions. Now, do you remember what reciprocal means? Reciprocal means flipping the fraction over. So the reciprocal of 2 over 3 is 3 over 2. Well, these are fractions. So if we flip these over, okay, those are the reciprocal functions and we give them a different names, right? So the secant is 1 over cosine. right? So think of it as the reciprocal of cosine, right? Cosine was adjacent over hypotenuse. Secant is hypotenuse over adjacent. Cosecant. Cosecant is the reciprocal of sine, right? Sine was opposite of hypotenuse. Cosecant is hypotenuse over opposite. And cotangent is the reciprocal of what? Can you guess? That's right, the reciprocal of tangent. Okay, so you could say there's 6, or you could say there's 3. If you memorize these 3, of course you're going to know these 3, because they're just the same ones flipped over. Okay, so there's 6 of them. All right? Okay, those are the 3 trig function and their reciprocals. Moving on. I know I did that fast. Let's use numbers now. So here's a triangle, and from the point of view, right, relative to this angle, okay, I'm going to ask for sine, cosine, tangent, cosecant, secant, cotangent, all 6 of them, right? Now I give you the numbers, so you don't have to say opposite. Just give me the actual numbers, right? 3, 4, 5. This is the hypotenuse. So if this is the angle, this must be the opposite, and this must be the adjacent, right? So what is the sine of this angle theta? Greek letter theta. What is the sine of it? Well, sine is opposite of hypotenuse, so it must be 3 over 5. What is a cosine? Well, cosine is adjacent of hypotenuse, so it must be 4 over 5. What's the tangent of theta? Tangent is opposite over adjacent, so it must be 3 over 4. You see how I'm doing this? Again, I know I'm doing it quick, but I'm just following the formula, the ratios that I gave you at the beginning. Now, what about the other 3? Well, the other 3 are just the reciprocals of the first 3, right? So cosecant is the reciprocal of sine. So it's just 5 over 3. 3 over 5, 5 over 3. Secant is the reciprocal of cosine. 4 over 5, 5 over 4. And cotangent and tangent are reciprocals, right? That's it. These are basically, if you can do this, it'll be so much easier to understand the rest of the chapter. You got to memorize sine, cosine, tangent. Okay? Then, what else did I want to say here? Oh yeah, before we go on, there is a way that you can memorize or remember which 2 are reciprocals. Notice that sine, cosine, tangent, the reciprocal have the word co. If it has co, then it doesn't have co. What am I talking about? Sine, right? There's no co there. Cosecant, there's a co there. Cosine, there is a co there. Secant, there is no co there. Right? So they go together. Tangent, there is no co there. There is a co in the reciprocal. Right? So in other words, the trig function and its reciprocal, one has co, the other one doesn't. If it has co, the other one doesn't. If it doesn't have co, the other one does. Wow, that's a lot of words. Okay, so one way we can make this question more interesting is if we give you one of these, and you should be able to get the other 5, right? Look at this one. So given one, find the others. Here, I'm giving you cosine. There is a right triangle with an angle, right? And the cosine of that angle is 2 over 5. Find the values of the other function. Now you might be thinking, how am I supposed to do that? I don't have the diagram, I don't have the right triangle in front of me, and I certainly don't have all 3 sides. Well, that's your job. Here's the hint. You draw the right triangle and find the 3rd side. Okay? So, a little good news. When you draw a triangle, right? When you draw a right triangle, you can put the theta, the angle, either one, here or here. It doesn't matter. Okay? It'll still work out. I chose to put it here out of habit, right? So if this is my angle and cosine is 2 over 5, so which sides have to be 2 and 5? Well, cosine is adjacent over hypotenuse, so the adjacent must be 2 and the hypotenuse must be 5. And I don't know the third side. Well, look what you have. You have a right triangle. Use a squared, b squared, c squared, right? A squared, b squared, c squared, and find the missing side. So I did the quick version, right? X is equal to square root of 5 squared minus 2 squared, okay? Ask me in class if you don't recognize this as the Pythagorean theorem. This is just a quick shortcut. And x is square root of 21. So now I know all three sides. 2, square root of 21, and 5. Now I can give you all 6 functions. We already know one. What is sine? Sine is opposite over hypotenuse. There it is. Square root of 21 over 5. What's tangent? Tangent is opposite over adjacent. Square root of 21 over 2. There it is. What's cosecant, secant, and cotangent? Well, those are just the flips of these three. This one, and this one. So what goes with cosine? Secant. So secant must be 5 over 2. There it is. What goes with sine? Cosecant. Well, cosecant must be 5 over square root of 21. There it is. And then I simplified it. What goes with tangent? What's the reciprocal of tangent? Cotangent. Well, that must be 2 over square root of 21. There it is. Oops, sorry. I'm sorry. So, one more time. Cosine goes with secant. So you see those are reciprocals of each other. Sine goes with cosecant. So you see those are reciprocals of each other. And then don't forget to simplify it. And tangent and cotangent are reciprocal of each other. Right? Don't forget to simplify it. Okay? So this was a case of we give you one of the functions and then use Pythagorean theorem to find the third side and get all the other 5 functions. Right? Okay. So could you try these problems? So this is like the first example. I give you all 3 sides and just give me all 6 trig functions, right? Sine, cosine, tangent, secant, cosecant, and cotangent, right? You have the numbers. The second one, I'm giving you the tangent. It's 1 over 2. Find the value of the other 5 functions. This is the one where you create your own right triangle, find the third side, and get all the other functions. Just like the second example. Did you see that answer right up there? Other 5 functions. Okay? We'll do that in class. Now, almost done with part 1. Almost done with part 1. Not yet. Okay. Where is the last page? Here. Okay. No, not this one. The one where it says special angles. Here it is. Sorry about that. Do you remember special angles? 30, 60, 45. Why are they special? Because with 30, 60, 45, we don't need 2 sides to find the third side. We just need 1 side, and we can figure out the other 3 sides. Right? In fact, if we start with 1, we can figure out the other 2 sides right away. 1 is the smallest or simplest number. So if you look at the 30, 60 first, right? 30, 60. If you have a triangle 30, 60, then the short leg, the long leg, and the hypotenuse are always known. They're always known. The short leg is 1, the hypotenuse is 2, and the long leg is square root of 3. Now, if I give you a blank 30, 60, right? Here's 60, here's 30, you should be able to put those three numbers here right away. Here's how I remember. Going counterclockwise, starting at the bottom, going counterclockwise. 1, 2, 3, square root. That's how I remember. Okay? So now that you have all three sides, right, you can do sine, cosine, tangent, and the other three reciprocals. 45 is also special. Okay? So for 45, the legs are the same, so they're equal, so 1, 1. And the diagonal, the hypotenuse, is radical 2, square root 2. So that's just 1, 1, 2, square root, right? So again, if I give you a blank, right, 45, 45, how do you know that's 45, 45? Because the sides are equal, so it has to be 45, 45. You should know where 1, 1, and radical 2 go. 1, 1. And you know how I remember? The slashes. These tick marks remind me of 1. So 1, 1, 2, square root. That's how I remember it. These have to be memorized also. You have to memorize these. You have to. So then, you could do this, but I actually write it down for you. What is the sine, cosine, tangent of these three angles? These are special angles. They're memorized. You don't need to see them. You can create your own, right? So sine 30 would be what? Opposite hypotenuse, 1/2, right? Cosine 30 would be what? Adjacent hypotenuse, square root 3 over 2. There it is. Tangent would be opposite adjacent, 1 over square root 3. And then I simplify or rationalize the denominator. Okay, how about for 45? Sine is opposite hypotenuse, 1 over square root 2, right? Rationalized. Cosine is the same thing, right? Adjacent and opposite are the same. It's the same thing. Tangent is 1 over 1, which is 1. And then 60, well, you can see yourself. So I should say etc., etc. Okay? So memorize sine, cosine, tangent, right? SOHCAHTOA. And memorize these two special triangles with the special angles. All right? I'll leave you with part 1 and this last try problems. So, oh, wait. This looks like... Oh, okay. Yeah, this looks like the other one. So you already have this. You already wrote this down. Okay. Wow, 18 minutes. All right. See you in part 2. Bye.